Hi everyone, and welcome back to the MCAT A series of lectures in physics. In the next two lectures, we shall be discussing two different small topics known as energy and work. Each of these topics will be a precursor to when they are actually used in further lectures. The first of these two topics is energy. Energy is typically defined as the ability to do work. However, as I have not defined what work is yet, we can also more broadly think of energy as what makes it possible for things to happen. As energy can cause different things to happen, there are naturally different types of energy. In particular, for the physics portion of the MCAT, the two types of energy you need to know about are kinetic energy and potential energy. After explaining what these are and giving examples of each, I will then discuss conservation energy, that is, that energy cannot be created or destroyed, it can only be changed from one form to another. I will then finish this lecture by talking about what is known as mechanical advantage, which, in a sense, describes the efficiency of applying a force. As I mentioned, energy is the ability to do work, or it is what allows things to happen. In metric units, energy is measured in joules, capital J. This, again, is a derived unit. It is equivalent to a kilogram meter squared per second squared. There are many forms of energy which I'm sure you are already familiar with. For example, electrical energy is what allows your TV to turn on. Chemical energy is what you process throughout your body and is what is allowing you to watch this video now. For the physics portion of the MCAT, the types of energy we are concerned with are what is known as kinetic and potential energies. Potential energy is itself split up into different types of energy. For example, gravitational potential energy and elastic potential energy. Each of these I shall discuss later in this video. There is also something known as mechanical energy. Mechanical energy is equal to the sum of kinetic and potential energy. As all of these are types of energy, all of them have units of joule. You can also see things like the kilojoule or the megajoule for large energies, or the nanojoule or the microjoule for small energies. Looking even smaller, as I mentioned in a previous video, you can also see electron volts, which deals with energies on the atomic scale. To begin, let us discuss kinetic energy. Kinetic energy is the energy associated with an object that is in motion. For example, if we have an object of mass m, moving at velocity v, then that object's kinetic energy is a half mv squared. This means that the heavier the object is, the more kinetic energy it has. Likewise, the faster the object is moving, the more kinetic energy it also has. An important thing to note is that while kinetic energy is directly proportional to mass, it is directly proportional to the square of velocity. That means that if you double the mass, you double the kinetic energy, but if you double the velocity, you quadruple the kinetic energy. You increase it by a factor of 4. Another thing to note is that I have written kinetic energy here as capital E, but sometimes on the MCAT you can see it in different ways. For example, you can see capital A, or you can see E sub k. All of these things mean kinetic energy. Naturally, as kinetic energy involves velocity, anytime there is an acceleration, there is a change in kinetic energy. For example, if we have an object that is above the ground, that object is obviously accelerating towards the ground. It is accelerating due to gravity at 10 meters per second squared. Therefore, as it is accelerating, its velocity is increasing, and therefore its kinetic energy is also increasing. The opposite is in fact true for potential energy, more specifically, gravitational potential energy. Gravitational potential energy is the energy an object has due to its position. More precisely, if an object is a height h over some reference point, for example the ground, then its gravitational potential energy is its mass multiplied by the acceleration due to gravity multiplied by that height. Therefore, going back to our previous example, if an object is falling, its h is decreasing. If its h is decreasing, then according to the formula, its potential energy is also decreasing. This idea will naturally lead us into the conservation of energy in a later slide. As an object is falling, its kinetic energy is increasing, but its potential energy is decreasing. Overall, what is known as its mechanical energy stays the same. It is conserved. This type of energy is known as potential energy, as it gives an object the potential to move and accelerate. Similarly, there is another type of potential energy you need to know for the MCAT, which is known as elastic potential energy. For example, if I consider this spring, which is attached to a wall on the left, then I can consider extending or stretching that spring with my hand a distance x. Doing this then gives this spring an elastic potential energy. That elastic potential energy is equal to a half k multiplied by that stretched amount squared. K is known as the spring constant. The spring constant K is an intrinsic property of the spring. It depends on the material that the spring is made out of. For example, a steel spring would have a different spring constant to a plastic spring. Note that the elastic potential energy equation is quite similar to the kinetic energy equation, a half something something squared. Gravitational potential energy, on the other hand, is not. It is simply mass multiplied by gravity multiplied by height. Again, just like for kinetic energy, you can sometimes see on the MCAT different letters representing both gravitational and elastic potential energies. For example, capital U is sometimes used for both gravitational and elastic potential energy. You can also see things like E sub P for potential energy, or more specifically things like E sub S for spring potential energy. Again, elastic potential energy is known as a potential energy because once you stretch that spring and let it go, it has the potential to move back again. It has the potential to accelerate. As I mentioned earlier, mechanical energy, which again I've used capital E for mechanical energy, but you may see things like E sub m, is equal to the sum of potential and kinetic energies. Again, in the example of an object falling under gravity as I discussed earlier, the object's kinetic energy is increasing because its velocity is increasing, and its potential energy is decreasing because its height from the ground is decreasing. Overall, its mechanical energy remains constant. Its mechanical energy is conserved. However, this is only in a very idealized situation. In general, in the real world, as an object is falling, it is also creating friction, which causes heat. That heat is a form of energy and it leaves the system, therefore leaving the system with an overall lower amount of energy. In other words, as the object is falling in general, the total energy of that object is decreasing. This is because energy is being lost to the surroundings. More precisely, we say that the mechanical energy is conserved when there are no non-conservative forces acting on the system. What do I mean by a non-conservative force? Well, we can split forces into two different categories, conservative and non-conservative. Just like displacement, which I discussed in a previous lecture, conservative forces are those that are path independent. Such forces are said to not dissipate energy. Such forces do not cause energy to dissipate into the surroundings. Friction is not a conservative force, it is a non-conservative force. It causes energy to be lost from the system. Energy is dissipated into the environment. Naturally, therefore, in the real world, non-conservative forces are impossible to avoid. However, typically on the MCAT, unless otherwise stated, you can assume that only conservative forces act on an object. One common exception to that is friction, and you will be told in the question if friction is acting on an object. Hopefully from the fifth question of the last lecture, you feel comfortable now dealing with frictional forces. Therefore, in summary, conservative forces such as gravity conserve mechanical energy. Non-conservative forces such as friction do not conserve mechanical energy as they dissipate energy into the environment. Anytime a non-conservative force is acting on an object, it does work. As I shall discuss more in the next video, anytime a non-conservative force acts on an object, that force is doing work. That work is equal to the change in mechanical energy. It is equal to the energy that is dissipated. Finally, I would like to discuss what is known as mechanical advantage. In essence, mechanical advantage is a measure of how good a device is at applying a force. To understand this, consider an object that is placed on a wedge or on an incline. Let us assume that we apply a force capital F to that object. Let's assume the question is asking us to find the force needed to push that incline up a total vertical distance of 10 meters. Well, because we are doing it on a wedge, it is naturally easier to push it up 10 meters than simply lifting it vertically. The force needed to push that box up an incline 10 meters vertically is naturally smaller than the force needed to directly lift it up vertically with our hands. This ratio of forces is known as the mechanical advantage. It describes how much of an advantage we get by using a device or a tool such as a wedge or an incline. In other words, mechanical advantage, which I have labelled capital MA, is equal to F sub out, which in this example is the force needed on the incline, divided by F sub in. F sub in this example will be the force needed to lift it vertically. An important point to note about this example is that the work done in both cases is the same. It is only the force that is bigger in one of the two situations. As we shall see in the next video, work is equal to the dot product of force and displacement. Therefore, although the force is smaller when using the incline, we have to push the block up further. There is a larger displacement involved. If we want to increase the block's height by 10 meters using a wedge or an incline, we have to push that block up further diagonally. In the case of lifting it vertically, we simply have a displacement of 10 meters. Therefore, overall, compared to lifting it vertically, the force is smaller in the incline case, but the displacement is larger. Overall, force multiplied by displacement, in other words work, stays the same. Again, as I mentioned, this is just a brief introduction to energy. In several videos following, we will discuss different types of energy and how to deal with them. Before doing so, let us look at some typical MCAT questions involving this introduction to energy. Question 1 states, in which of the following instances is the increasing kinetic energy of an object the largest? Increasing its mass by a factor of 3, increasing its height from the ground by a factor of 5, increasing its velocity by a factor of 2, or increasing the acceleration due to gravity g by a factor of 4. Well, let's recall the definition of kinetic energy. Kinetic energy is equal to a half mv squared, a half multiplied by the mass multiplied by velocity squared. Therefore, the only quantities that enter into that are m and v. Thus, the answer cannot be B, because that involves the height from the ground h. That enters into gravitational potential energy, but not kinetic energy. Similarly, the acceleration due to gravity, small g, enters into gravitational potential energy, but not kinetic energy, so option D also cannot be correct. For option A, as kinetic energy is directly proportional to mass, E is equal to a half mv squared, if we increase the mass by a factor of 3, then we are also increasing the kinetic energy by a factor of 3. However, velocity is not directly proportional to kinetic energy. Kinetic energy is proportional to velocity squared. That means that if we double the velocity, we increase the kinetic energy by a factor of 4. Therefore, for option A, we have increased it by a factor of 3, but for option C, we have increased it by a factor of 4. Therefore, the largest increase is for option C. The second question is testing our knowledge about mechanical energy and when it is conserved. Is mechanical energy conserved when only conservative forces act on an object, either the kinetic or the potential energies remain constant, only non-conservative forces act on an object, or neither kinetic nor potential energies remain constant? Well, let's recall our definition of mechanical energy. Mechanical energy is defined as the sum of kinetic and potential energies. Therefore, if only one of the two is constant, we cannot say for certain if mechanical energy is conserved. If one is constant, the other may be changing, and therefore mechanical energy may be changing. Option D is also incorrect. Again, going back to our example of an object falling to the ground, in that case, the kinetic energy is increasing and the potential energy is decreasing. Neither the kinetic nor the potential energies are constant. However, we cannot assume that just because neither of them are constant, that mechanical energy is conserved. For example, in that scenario, if energy is being lost due to friction, then they are both changing, but mechanical energy is not conserved. This means that option D is also incorrect. Therefore, our answer is either A or C, either when conservative or non-conservative forces act on it. Well, let's recall what a conservative force means. When a conservative force is acting on an object, energy is not lost from the system. It is only non-conservative forces, for example friction, that cause energy to dissipate, energy to be lost from the system. Therefore, the mechanical energy is said to be conserved only when conservative forces act on the object. This means that option A is the correct answer. To finish off, we have a question that has some numbers in it. We are told that a 1 kilogram object is dropped vertically with a speed u. In other words, the object is not just simply let go, it is thrown down at a vertical velocity u. It is dropped with this velocity u from a height of 5 meters. We are also told that the object's mechanical energy after 10 seconds is 68 joules. The question also tells us that there are no non-conservative forces acting. We are told that we can assume that air resistance is negligible. We are then asked to find the value of u, the velocity at which the object is dropped. Is it 3, 6, 9 or 12 meters per second? Well, as always in questions such as this, it is a good idea to draw a diagram. We have a 1 kilogram mass that is 5 meters from the ground. It is also a good idea to think about what variables we know from the question. We know the mass is 1 kilogram, so m is 1 kilogram. We also know that the height h is 5 meters. The question also tells us the mechanical energy after a certain time. The mechanical energy, which remember is a sum of kinetic and potential energies, is equal to 68 joules. We are told that the object's mechanical energy is 68 joules after 10 seconds. However, this 10 seconds is a bit of a red herring. Remember, because there are no non-conservative forces acting, the mechanical energy is conserved. Therefore, the mechanical energy is 68 joules at all times. This 10 seconds is not a useful number. It is not a number we need. As we are told the mechanical energy, and as we are looking for a value of something at the start, the initial velocity of the object, let us now work out the mechanical energy initially. We know that it is 68 joules, but let's see if it gives us some information. Therefore, initially at t is equal to 0, the kinetic energy is a half mv squared, a half multiplied by the mass, which is 1, multiplied by the velocity initially, which we're told is u, so u squared, that is what we're looking for, and that is simply equal to u squared over 2. Initially at this time, the object is also at a height of 5 meters. Therefore, its potential energy is mgh, which is simply 1 multiplied by g, which is 10 meters per second squared, multiplied by height, which is 5. Working this out, we get that the potential energy is 50 joules. Therefore, we have that the kinetic energy is u squared over 2 and the potential energy is 50. The overall mechanical energy is the sum of these two quantities, kinetic plus potential, u squared over 2 plus 50. However, again, we know what the mechanical energy is. We are told that it is 68 joules after 10 seconds, but because there are no non-conservative forces acting, this is the mechanical energy at all times, including at t is equal to 0. Therefore, u squared over 2 plus 50 is equal to 68. This is now one equation with one unknown. We can solve this equation for u, which is what we're looking for. We get u squared over 2 is equal to 18. Therefore, u squared is equal to 36. And therefore, u is equal to the square root of 36, which is 6 meters per second. And therefore, the correct answer is option B. So again, as I mentioned, this is just a brief introduction to energy. This is not the last time we are going to see energy. We are going to discuss different forms of energy as the lectures progress. The purpose of this video was just to give you a short introduction about what energy is and the typical forms and types that you need to know for the MCAT. For example, I defined what energy was. Energy is the ability to do work. However, as I have not discussed work yet, I instead said that energy allows things to happen. Energy has units of joules, which again is a derived unit. I then moved on to talk about two types of energy that you need to know about for the MCAT. For example, the kinetic energy of an object is the energy associated with that object because of its motion, because it is moving. That kinetic energy is equal to a half mv squared, a half multiplied by the mass of the object, multiplied by the velocity of the object squared. Potential energy is the energy associated with an object due to its position. It is known as potential energy as that object has the potential to accelerate, to move. There are various types of potential energies, two of which you need to know for the MCAT: gravitational potential energy and elastic potential energy. Gravitational potential energy is the energy an object has due to its position in a gravitational field. Gravitational potential energy is defined as mass multiplied by acceleration due to gravity g, multiplied by the height h from some reference point, which is typically taken as the ground. The elastic potential energy, on the other hand, is the energy associated with a stretched spring. If a spring is stretched a distance x, then its elastic potential energy is a half kx squared, where k is the spring constant and depends on the material of the spring. Then I discussed the idea of mechanical energy, which is the sum of kinetic and potential energies. I then described how mechanical energy can be conserved as long as there are no non-conservative forces acting on that object, no forces that dissipate energy from the system. Finally, I introduced the idea of mechanical advantage, using a device to minimize the force. I then ended that section by emphasizing the fact that although the use of a device or tool can decrease the force needed, overall the work remains the same. As we shall see in the next video, work is the dot product of force times displacement, and therefore because the force has decreased, the displacement must have increased because work has to stay the same. Thus, I shall discuss work in my next video. I will define more precisely what it is and how it relates to energy. If you feel comfortable answering typical questions on the MCAT about energy like those I've just presented, then please feel free to move on to the next video. Thank you guys for listening, and I'll see you in the next one.